Question 24 reads as follows. We define S of n as the sum of the digits of a positive integer n. And they give examples here. So S of n, the meaning of it is you take the number and you add the digits. If you take, for instance, 2,156, S of that is equal to the sum of the digits of that number. So if you add these four numbers, you get 14. So S of 2,156 is 14. Okay. So the question that is asked is to find the sum of all the SNs, but these, if you'll notice, the signs change, minus, plus, and so on. And that is the question. All right. So let's try to see what these S's are first. I'm going to go into a new page. Let's look at the sequence. I usually put a less than sign to denote a sequence. Okay, so you have S of n. When you add the digits, the one-digit number, they don't change. The first change occurs when you come to 10. S of 10 is 1 plus 0. And after that, it keeps increasing. Now this is S of 17, 1 plus 7. S of 18, S of 19 is 1 plus 9, which is 10. S of 20 is 2. 21. I'm writing all these things down because you can see it's a somewhat erratic sequence. You know, some funny things happen. Yeah, from 9 it jumps to 1. From 9 it jumps to 10. So there are some difficulties obtained when you move from 19 to 20, 20 to 21, 29 to 30, and so on. Okay, let's not worry about that for the moment. Let's look at our sequence that we are actually examining, and that is Tn. I'm going to call this Tn, namely the Sn with the proper sign. So we'll notice that all the it's 1 and then minus 2, 3, minus 4, because at the even spots you had a minus sign. See here, minus S2, minus S4, and at odd they are the sign is plus at the odd numbers. Okay, so if you look at the sequence, 5, minus 6, and so on. Okay, so this is the sequence under consideration, and you're adding, you want to work out S1011, if I got it correctly. So you need to, the sum of the first terms of this sequence. So let's call this Rn, that R and be the sum of the first n terms of Tn. And we had 1, minus 2, plus 3, minus 4. And then we need to calculate this sum up to 1011. So we need to work out R 1011. Just remember that. And this is the sum of the first 1011 terms. Okay, now it looks as if it's going to be quite tricky here because these things are start jumping at every, like 19 and 29 and so on. And by the time you get to 1011, there are lots of jumps. You have over 100 jumps. Okay, so how do you handle those things? It turns out that it doesn't present a problem, as we shall see. Okay, let's write down Rn as a sequence. I'll mentally add these. 1 minus 2 is minus 1. Right, so when you add these two, you get minus 1. Now you add 3. Right? Like this is 2. And then you add minus 4. 2 minus 4 is minus 2. So you come up to this. This minus 2 plus 5 is 3. Okay, and then you go on to this. Up to this point is 3. 3 minus 6 is minus 3. Okay, let me do just one more. You come up to minus 6. You're adding 7 now. Plus 7. And then you add minus 8 to this. So you see that Rn is this sequence. And perhaps when it comes to this one here, you have some problems. And here you have some problems as well. So I'm not going all the way to that. But what I want to notice is the following, that the odd terms, first, third, fifth, seventh, and so on, they all are equal to the natural numbers, 1, 2, 3, 4. In other words, the first term is 1, the third term is 2, the fifth term is 3, the seventh term is 4, and so on. So we can say this is an observation. And that is the R of, now we'll make this thing here, the odd numbers are 2n plus 1. So R of 2n plus 1, actually let's make it 2n minus 1. Because I want the odd numbers can be written as 2n minus 1 or 2n plus 1. In fact, you can put 2n plus any odd number. But normally it's 2n plus 1 or 2n minus 1. And if I use n equals 1 in this becomes 1. N equals 2, it becomes 2, you see. So then it's n equals 2 is R of 3, and you know it's 2, and R of 5 is 3. So we claim that R of 2n minus 1 is n. So this is a claim, observation. So how do we prove that? Let me create some spaces here. Okay, so essentially, in other words, we want to show that the odd terms form an arithmetic sequence. Right? It's an arithmetic sequence. And all we need to do is to show, we know the first term is 1, and we need to show that the common difference between two of these odd terms is always going equal to 1. Right? So this is how we prove it. So we shall prove that if you take any two consecutive terms from the sequence, okay, it's R of an odd number. So take R of 2n plus 1, and the one just before that is that, is it the 7th term minus the 5th term, or the 9th term minus the 7th term. So you can write this in general. We should prove that this is always equal to 1 for all values of n. Okay, let's do that. So what do you have? You have R of 2n plus 1. Now remember, this is the sum of the first n terms of the t's. So this is t1 plus t2 plus t3. But here you'll have to go up to 2n plus 1. So you got put 2n minus 1 plus 2n. The next one is plus 2n plus 1. And R, that takes care of that. Now you take 2n minus 1. It's the sum of the first 2n minus 1 terms. So you'll stop here. Okay? And so when you subtract these two, most of them disappear. All these will disappear when you subtract. These are the only two survivors. T of 2n plus T of 2n plus 1. So now we need to work out, at this stage here, I'm going to try to work out my R1011. So if 2n plus 1 is equal to 1011, that's what I want to calculate. Now, wait a minute. Um, Oh yes. Right. You notice our T. Let's not do that. Let's look at the TN sequence. Let's recall that. The T2n sequence, the TN sequence is 1, -2, 3, -4, and so on, right? So at the even terms, you got -2, and at the odd terms, you got +2n plus 1. So this is equal to -2n. T of 2 is -2, or the even ones. And here, it's +2n plus 1. But you will say, hey, wait a minute, this is not always the case. Because when you come to '19, when n is 19, there's a jump here. When n is 29, there's a jump here. All right. But you'll notice that there's a jump if the first term is odd. Now here the first term is even, so there's no jump at 20. 20 and 21, you got T of 20 is 2, and this is 3. See? So actually you don't have, it's not necessarily 2n. It's yeah, I must just be a little bit careful here. But what I want to say is that at those spots, let's just take these things out. I got an even number in the front and an odd number. So, for instance, I can take 97 and 98 and 99. Right? This is T of this is 17. 9 plus 8 is 17. But at 2n it's even, so it's -17. And this is +18. So this is equal to 1. Right? If the first number is 98, it's like that. And then but when you come to even 1,000, 1,001, this is -1, it's even, +2, still equal to 1. But when you have 99 and 100, this is 9 plus 9 is 18. So it's odd. So it's 18. And this is 1. There's a minus sign. And this is not equal to 1. But the point is, if you got a pair where the first one is even, you'll always get the answer 1. So there's a pair, T2n plus 1. And this will always be equal to 1. Right? If it starts an odd number, then you may have a problem at these cracks where you are looking at T of 19 and T of 29 and so on. So this is always 1. That's very important. So in other words, it is quite true. What we have said is that the difference is always equal to 1. This is what we have proved. The difference between two, the R's of two consecutive odd numbers. These are consecutive odd numbers. So always 1. So we've shown that the odd terms form a arithmetic sequence. In particular, the question that they asked us was T of R of 1011. Remember, this is the sum of the first. So this is an odd number, you see. So the R of the odd number is always n. R of 2n plus 1 is n. Right. So this is R of, this is 2 times 505 plus 1. No, we had R of 2n minus 1. Sorry. Yeah. Remember, we changed that. R of 2n minus 1 is n. Okay. So this is 2 times, it's 1012 minus 1. So that's twice 506 minus 1. So your n is 506. So this is the answer to that question. They asked R of an odd number. So there, you know, we know what happens to the odd numbers. For the even numbers, we might not know, but for the odd numbers, we have this. All right, so there we go. That's the answer to that question. It's quite a deep question, but this is question 24. So it always gets more and more difficult as it goes along. You remember the very first questions were very trivial, board maths and all that. Okay, so let's get on to the, let's check our answers and I will show you the answer that I had prepared in advance. There it is. Right at the end, you've got R of 2n minus 1 is 506. Okay. Okay, now we get on to the last question, which is question 25. This looks like a geometry question. You got square ABCD as sides length. So you got a square whose side length are 10, as you can see, it's written here, and is placed over 2 parallel horizontal lines, and they are 10 units apart. So these 2 horizontal lines are 10 units apart, but the square is tilted like this, and there is a piece, a triangle which is jutting out on that side, this triangle which is jutting out on this side. They are colored. What is the sum of the perimeters of the triangles, these 2 colored triangles? So the perimeter of this plus the perimeter of this, what is the sum of the 2? That looks like a very tricky problem. We don't know what the tilt is. Could be a high tilt or low tilt. The question suggests that you'll always get the same answer. Right? Now that is quite a useful piece of information. That no matter what the tilt is, it's got nothing to do with the tilt. It just says this: the perimeter of this plus the perimeter of that. Perimeter means the sum of the 3 sides of these 2 triangles is always equal to the same thing. So a clever student will say, well, I'm not going to think too much about this because what I can do is take, since it doesn't really matter what the tilt is, I can Maybe if I tilt it, if I don't tilt it at all, I get zero tilt. Then what do I get? I get a square like this, and the 10 comes right down here. I got 10 down here. So this is the square. Right, but there's no tilt. Now remember, the original tilt was 𝐴𝐵𝐶𝐷, the original square. So let's put down your A, the B is down here, the C is here. Oh, this is supposed to be C. Not very clear there, right? But there's no tilt. So this triangle 𝐴EF, right? The F, when I put this thing, I'll treat it that way. So the F becomes D. This is the same as F. And here, when you put it down like that, then the B is on this side, the C corresponds with the H. So this is H. And the B is G. And the A is E. All right. So in this case, some of these points coincide. The intersection of this line with the horizontal line is D. The D is not in between, it's on that line. That's what I've got here. Okay. Now these triangles now become degenerate, right? In the sense that one of the sides is 0. So you still got AEF, right? But AEF is a triangle where one side is 0 and the other two sides are the same. So AEF is actually there's just one side. So here you have 10, the perimeter. A perimeter of a triangle which has got one side 0 is, so you come here and that side is 0, so you have to stop right there. So you have that's the perimeter of ADF. AEF. And the same thing at the bottom, this is the perimeter of CGH. That's that triangle, the triangle. So your answer is 10 plus 10, which is 20. So you can say, without doing any calculation, you can say, since it's independent of the tilt, in this special case, you should have the same, the answer to that question. And the answer is 20. Okay. Now, in the actual competition, if you got this answer, you should get full marks, right? Because they just wanted to know what the sum of the perimeters is, and you wrote down the answer. And but you have to argue that in the special case, we look at the special case and the answer is 20. So since the sum is, they suggest that it's independent of the tilt, therefore the answer is 20. But now if you really want to prove this thing, you can show that this perimeter plus this perimeter is always 20. And that is what I'm going to do now. I'll try to show that the perimeter is always 20. That involves a little bit of mathematics calculations. So let's do this. Let's go ahead. All right, so now you've got quite a difficult thing to prove here. You want to prove that if you call this A, let's put a black. So you call this A, B, C, and you call this D, E, F, right? So you got these 6 sides. Now you have to calculate. The problem is the perimeter of the top is A plus B plus C plus the perimeter of the bottom. It looks like a frightening problem because you don't know any of these sides. They only know that the square has got side 10 and the distance between these parallel lines is also 10. That is all you know. Okay. I want to show that this is always 20. Looks like a very difficult problem. Okay, let's give a name to the tilt. Let's call that angle theta, right? We saw that for theta equals 0, if there's no tilt, then the answer is 20. But now we want to show that it's still 20 no matter what the theta is. If this is theta, this angle here is also theta here, because these lines are parallel. So this is between these 2 lines, and these 2 lines are parallel to those 2 lines. So the angle between them is the same. Right? Now, before I go on, I want to just state a useful fact. And that is that in a right angle triangle, given the hypotenuse, let's call it H, if this angle is theta, then this can be written in terms of H and theta, because whatever this is, let's call it X, the cosine of theta is adjacent over hypotenuse. So X is H cos theta. So in place of X, I can write down H cos theta. So you look at this, and this line is adjacent to theta. So it becomes H cos theta. This line here is opposite theta. So this one here is H sin theta. Okay. So that allows me to rewrite the perimeter here. So A plus B plus C. Now the hypotenuse is C here, right? And the angle here is theta. So, and if you look at A is opposite theta here. This is a right angle triangle here because this is a square. So this A is now C sine theta. And the B is adjacent to theta. This is the hypotenuse. So B is C cos theta. And leave C as it is. And then we'll go down to the bottom. The D, the hypotenuse here is F, and the D is adjacent to theta. So that becomes F cos theta. It's a hypotenuse cos the adjacent, and the E is the hypotenuse sine the adjacent. And the F is hypotenuse, it just remains as it is. So, this is I'm adding the whole lot. I can just put the equal sign here. So these 6 unknowns have actually been replaced by 3 unknowns. I got C, F, and theta. All right, we can take out C into this is sine theta plus cos theta plus 1. And here is plus f into cos theta plus sine theta plus 1. So you got a common factor. So this is equal to C plus f. The common factor is sine theta plus cos theta plus 1. All right, so this is the, we'll call this P for perimeter. It's actually a sum of two perimeters, but that's fine. So we've got this formula. I'm going to, I'll be needing space. So I'm going to write this formula at the top and rub the rest of it out, rub the rest of it. Erase all this. So I'll just record this formula. P equals C plus F into sine theta plus cos theta plus 1. Okay. Now, I'm going to I'm going to draw a line Yeah, okay, I think I know what I'm going to do. I'm going to draw a line from here, drop a perpendicular here, right? And then, in fact, I'll go all the way down. And I'm going to calculate the sum of these two. These sum of these two lines, let's just put two different colors here. I'll make this top part say red and black. I'm going to calculate the sum of these two. The sum of these two is 10. All right, so sorry, I want to get my black back. Okay, I'm not sure whether I'm doing the right thing here. But let's take this. Let's call this X and Y. Now, when I draw perpendicular, I'm drawing the distance between these two. That's going to be equal to 10. If that is theta, then this is theta. So this theta plus this is 90 degrees. and this plus that is 90 degrees. So you've got theta there, and this theta here, theta plus this is 90 degrees, theta plus this is 90 degrees. So this is theta here. Actually, these are vertically opposite angles, so you could do that. Also notice that this part here is 10 minus b. The whole thing is 10. We called this b. So that's 10 minus b. Somehow, this whole thing here is 10 minus e. That's not going to help us too much. Okay, maybe I'd better do this. I'm in the wrong place here. I should have. What I'm going to do is, let's just forget this. Sorry, this is how mathematics is. A lot of trial and error before you eventually get to something. Now that one doesn't seem to be getting anywhere. So I'm going to draw the same thing on this side, because I know this is 10 minus a, you see. This is 10 minus a. I'm going to make that the hypotenuse. Right. To do that, I'm going to drop a perpendicular, draw a right angle triangle here. Right. This is, and then I'm going to, this is d, so I'm going to make this 10 minus d. That the whole thing is 10. It's 10 minus d. And I'm going to make this the hypotenuse. So what you have to do is extend this line, go up to that, right? So make that the hypotenuse. The reason is now I can see that this thing here and that, when you add those two, you're going to get 10, right? So I'm going to put on 10 equals. Now this part here, okay, now there's, let's see, there's a theta here somewhere. This is 90 degrees. And this one here is 90 minus theta. So when you add these two, this plus that is the same as this plus this, which is 90. So this has to be theta. And likewise, the theta was here. So therefore the theta goes there, because this angle here is 90 minus theta. And so that has to be theta. This angle here is theta. Right, so these two arrows here, let's call this x and y. So 10 is equal to x plus y. Right? Now, what is x? You got the same thing that I was talking about earlier on. This is 10 minus a. The x is adjacent to this hypotenuse, which is 10 minus a. So this is 10 minus a cos theta. You see? This is adjacent. So x is hypotenuse cos the adjacent angle is equal to x, right? That's your x. And y, in this case here, you got hypotenuse 10 minus d, and y is opposite theta, so it becomes sine theta. Okay. Okay, so what you have here is if you take the 10 out, you get 10 cos theta minus A cos theta plus 10 sine theta minus D sine theta. Or it's actually supposed to be F. All right, I'll have to make some other adjustment here. Anyway, minus D sine theta. And what I'm going to do is work out sine theta, take 10 out, and you get cos theta plus sine theta. Yeah, and you get minus A cos theta minus D sine theta. There's a 10 on the other side, so I can make this thing A cos theta plus D sine theta. Bring this side, and that take the 10, and you have cos theta plus sine theta. Bring the 10 on the other side, you have minus 1. So you see you've got this kind of a thing here. So I can make sine theta plus cos theta plus 1 the subject here. So these two equations are important here now. Now what is A cos theta? A so these equations are important. I'm just trying to figure out what you do with these. Let's take out all these calculations. Eventually I'll land with the problem is I've got C plus F here. And here I've got A and D, which are adjacent. And sorry, let me look at my answer. I have to look at my own answer to see. I seem to have taken the wrong one. I got two equations which involve the same numbers. Okay. Okay, now I know what I did. Right. So you got the following. This, remember what A was. right? I'm going to replace the A and the B. The A is C sine theta, right? So what you've got here is I'm going to put down here 10 into cos theta plus sine theta minus 1 equals A cos theta plus D sine theta. I should have noticed this. This is A. I'm going to replace A by C sine theta. Remember, A is opposite theta, and this is the hypotenuse. So A, I'm going to make it as C sine theta times cos theta. And the same thing with D. D is F cos theta sine theta. So F is, yeah, I need a D. D is this one here. So it's the hypotenuse cos theta. Now you can see I got C plus F into sine theta cos theta. I got cos theta, sine theta as a common factor. And now you see I got C plus F twice here. That's what I was trying to get. And I was wondering why I got so many symbols, but I could have got both of them to be aligned like the way I did now. Okay, so this is where we are. I'm going to make C plus F the subject of the formula of these two. So therefore, the C plus F, which is P over sine theta plus cos theta plus 1, that is your C plus F from the first equation. From the second equation, it's 10 into cos theta plus sine theta minus 1 over sine theta cos theta. That's from the second equation. This over sine theta is C plus F. Right, so now ignore C plus F. I've just got P and theta here, see? And I'm trying to calculate P. So cross multiply, you get P sine theta cos theta is equal to 10 into cos theta plus sine theta minus 1. And this one here is the same thing, but I'm going to put cos theta plus sine theta. I had sine theta plus cos theta. I'm going to make it cos theta plus sine theta, but plus 1. So here you've got x minus 1 into x plus 1, where the x is cos theta plus sine theta. So this is, by difference of two squares, this is 10 into, I'm just going to multiply these. It's cos theta plus sine theta. X minus 1 into x plus 1 is x squared minus 1. Okay, so you got 10 into cos theta plus sine theta all squared minus 1. Now, so this is 10 into, now the square is going to be cos squared theta, and here the middle term is 2 sine theta cos theta plus sine squared theta. I'm squaring this, right? This squared plus the middle term plus sine squared theta minus 1. But cos squared theta plus sine squared theta, no matter what theta is always 1. So that is 1, and then 1 minus 1 cancels, right? And on the left-hand side, On the left-hand side, I've got P sine theta cos theta. On the right-hand side, simplifies very nicely because that one goes off. 10, I got 10 outside, so I got 20. 10 times 2. Sine theta cos theta. How about that? Cancel that, and you get P equals 20. This is an amazing calculation. 6 unknowns and destroyed them and using trigonometry and other things. So this proves that the sum of these 6 things is always 20. And we saw in the special case, it was 20. We got the answer anyway. And that brings us to the end of the 2022 senior round 2 paper. Thank you very much for listening.